This, I think, fairly short video is going to be a little demonstration regarding Chapter 13 and pressure in a liquid. I'm going to add something to this basic demonstration that I've done before. I'm going to add something to it that I've never done before. But in fact, I haven't even practiced it. So we shall see how it goes. First of all, I wasn't thinking about the fact that I can't get to my beakers with these. Well, I'll just do it from the other side. Notice, please, that the two beakers here are filled to the same level. Don't pay any attention to the, actually, they are about the same volume. This is at just over 400 milliliters. This is also just over 400 milliliters. I didn't realize that they were the same capacity beakers. Good. That's even better. Now, here's the cool thing. I've got this hose in here, and the hose is completely filled with the same pink water, just food coloring in water. Right now, the pressure on this side is the same as the pressure on this side because the depths are the same. Recall from Chapter 13 that depth in a liquid depends only, pressure in a liquid depends only on the depth. So right now the pressures on both sides are equal. But what if I increase the pressure on one side? How can I do that? Well, remember that the shape of the container is irrelevant. So this container, it's actually one container. From here through the tube to the other side and all the way to the bottom, it's one container. So I can increase the pressure on this side simply by lifting the beaker. If I lift the beaker, then there's greater pressure on this side than on this side. Therefore, the water is going to flow from the region of higher pressure to the region of lower pressure. Watch what happens as I elevate this side. So now the depth from here to the bottom of the entire container is greater, so we've got higher pressure here and lower pressure here, and notice what's happening. This one is going down, down, down. This one's going up, up, up. When will this one stop going down and that one stop going up? Well, when the two pressures are equal, when there's no more difference in pressure, when they are at exactly the same level. And it looks like they haven't quite gotten there yet. Still there's movement. It's still flowing from left to right through the hose in the middle. And it's still flowing ever so slowly. The pressure difference is very little now, so it's slowing down, but it's still moving. The left one is still sinking ever so slightly. The right is still filling ever so slightly. And looks like maybe it's reached equilibrium about now. I can reverse that, of course. If I put this on the other side, then I'm going to have higher pressure on the right, lower pressure on the left, and the process reverses itself. And the one on the right is sinking, while the one on the left is rising. And they will both equalize again when it gets to, where was that? A little bit above 400 milliliters. It will stop moving. Now, as you meditate on that, I'm now going to prepare for the part of the demonstration that I've never done before, I don't believe, at least not with colored water. All right, I have here a container where I am safely keeping another hose with blue water in it. Got the pencil stuck in there to keep water from leaking out. And my main fear here is that I'm going to make a mess. But I'm going to do everything I can to keep from making a mess. I'm going to take that pencil out, but before I take the pencil out, I want the two ends of the hose to be pretty much equal. In fact, to play it safe, I'm going to put my thumb over this one and pull the pencil out of this one. As long as my thumb is in there, then nothing's going to happen if I change levels. If I take my thumb off, then the two sides of the hose will maintain equal levels. Notice if I go down here, The level on the right rises, level on the left goes down. If I go up like this, it reverses. If I go up too far, then the water's going to start pouring out of the left side. I don't want that to happen because I don't want to stain anything with this blue food coloring. Now here's the tricky part. I now add a third beaker, which is also filled to the same level as the other two, to the best of my ability. I'm now going to put my thumb over one side. You can't see me right now, but that's all right. Okay, I'm going to stick this down into the new beaker. Whoop! Oh, that was a failure. I failed. Yeah, I wasn't thinking. See, this is the first time I've ever done this. I didn't mean to empty out half of that hose. That's not what I wanted to have happen. Bummer. Can I recover from this? I think I can. I think I can. Okay, while you watch me struggle here, I'm trying to get the bubbles out of the hose. Okay. I have now almost successfully gotten the bubbles out. Come on, bubble, go away, go away, go away. All right, bubbles are out. Now, I'm going to try to, I'm sorry, this is, that little accident was certainly not planned. I'm going to lift the new beaker up and put the hose down here into the, okay, there we go. Yeah, this colored water idea is not performing as anticipated because of my blunder. Maybe I could have done better, but I didn't. I'm now going to tape the hose to the beakers so I don't have any other accidents. Those of you who have ever cleaned a fish tank with a little water vacuum hose, you know what I'm talking about, that if one of these pops out, then I'm in trouble. All right, well, that's not going to be the greatest, but here's the concept. I now have all three beakers connected together by two separate hoses, as you can hopefully see. If I lift this one, watch what happens. I put this one up high. Now I got higher pressure here and lower pressure in both of these. So what's going to happen is, let me move this over toward the left some so you can see it better maybe. This one's going to go down, of course, higher pressure pushing through the hose. It's going to cause this one to fill up. But as this one fills up, now it has higher pressure than that one. So the liquid's going to go from this through the new hose into that one. Now, you see what I was trying to do with the colors? I thought maybe we could actually watch the colors flow through the tube, but that's not happening. We can, however, see that as this one goes lower and this one goes higher, this one is also going higher. Maybe I can turn it around so you can see the milliliter markings. So right now it's at about 750 something, and it's slowly coming up on the right beaker. And when will they stop moving? Well, they'll stop moving when all three are equalized. And the left is still coming down. It's approaching 250. The middle is about leveled off, and the one on the right is still rising ever so slowly, approaching its 850 mark. And they will stop moving when all three sides are equal in depth, when this pressure, and this pressure are all the same. Notice it's not dependent on how deep the water is here. It's dependent on how deep the water is in the entire container. The whole container goes from here to the tabletop, because the container consists of 3 beakers plus water in the hose. So we're talking about the depth here. Well, now the depth here, and the depth here, and the depth here are all approximately equal, and movement has pretty much stopped. It looks to me like the middle beaker is still a little bit on the high side, which means that it's not quite done stabilizing yet. The right one still has to get a little bit more in there. So this is working very nicely. What would happen if I did this? Let's try, I'm going to move the left one down to the table and move the middle guy up to the top. Rearrange things a little bit here, and we'll watch what happens now. Of course, you know what's going to happen. Let's see. This one has the highest pressure. It's going down rapidly. This one is certainly higher. This one is the lowest. It's filling up because it has low pressure. High pressure liquid forcing itself through to the area of lower pressure. And again, this will continue bebopping back and forth like this until everything is at the same level. Pretty cool, huh? Just have to be careful. Yeah, I know that it's impossible for this to rise any higher and go over the top because the average of the three has to be someplace between those three, so they can't possibly fill up this beaker. It will not overflow. And they're coming back to equilibrium slowly but surely. The one on the right is still going lower because it has to. The one on the left is still rising higher. The one in the middle might already be now at about the right place, so it may have already stabilized. It's pretty cool how they kind of coordinate their efforts. Well, they're not actually coordinating. They're simply flowing until the pressure on all three beakers is the same. It's a pretty cool concept. They've stopped moving. No, I know they have not stopped moving. They may be moving slowly, but physics dictates it's not possible for them to have stopped moving yet because they're not all at the same level yet. This one is still coming up a little bit. This one is still coming down a little bit. And if we were to wait long enough, we would see them all finally. Now, this one is just now coming down to that 900 mark. There, it just hit the 900 mark and still sinking. This one is approaching the 800 mark, and it is at the 800 mark right about now. So, yep, they're going to keep on moving ever so slightly. They're almost equalized now. Pretty nifty, huh? I'm noticing that from the perspective you're seeing in the viewfinder, it looks like this one's higher than that one. But that's because I have the camera a little bit too low. How about if I raise the camera some? There. Oh, yeah. Mister, you could cheat that way. You could make them look equal when they're really not. Yeah, I know I could cheat. But actually, we need to go a little higher to get it. I'm trying to get the camera lens level with the top of the water. And that's right about correct there. Oops, it's sinking. My camera's sinking. Lock that in place. All right. Now, so we've seen enough of that, I think. It's a pretty cool concept there. I love it. I love it. Let me show you a practical application. Before I show you the practical application, though, I want to detach the tape on these guys and give you a possible practical application of this whole thing. I'm going to pull this out, put my thumb over it to keep too much water from coming out. And I want that to be lower, yes, okay. All right, I now have this hose almost full of water. It's pretty good. I'm actually going to get rid of some more of the water in here. Oh, that was more than I expected, but that's okay. Everything's fine. Now, let me also reposition the camera, so pardon me a moment. Because I'm only one-handed right now, I'm not going to try to raise the whole camera. I'm just going to angle it up, so the angle might be a little bit awkward, but that's all right. And let's zoom in on the board. Okay, so you're looking up at me. Okay, hi. So here we have the same thing going on. Paul Hewitt mentions that this right here could be used to figure out if you're maybe building a deck in the backyard. And for some reason it's important to you to have the deck in the backyard at exactly the same level as the porch in the front yard. Well, that can be a little bit difficult unless you have a long hose filled with water. Because if you get this hose in the backyard, get the water level right at the top of your deck, and get this hose in the front yard, you know that the water levels here are at exactly the same elevation. They always will be. Notice what happens if I lower the hose on your left. See how the water kind of trades places. If I lower the hose on the right, again, they trade places. Pretty easy for me to accidentally raise this one too high and have the water flow out of the tube, but I'd rather not do that. I'll make a mess. Also worth noting, as you may have noticed in the other demonstration, you know something, you might not be able to see that very well against the red background of my shirt, sorry. And that background's not the greatest either. Tell you what, let me get a white background for you here. Can I do that? Yes, white background. CLS background. Okay, so that's better. Now you can see what the water's doing as I raise this one, as I lower this one, and we see the water bebopping back and forth. I trust you can see that all right. But the level in the two sides of the hose remains constant because the pressure has to be equal on both sides. When I do this, all of a sudden, the pressure on the left side was momentarily higher than the pressure, no, on your right side. The pressure on your right side was momentarily higher than the pressure on the left, so the water flows until it's once again equal, and that just keeps on going back and forth. Whoops! Oh, I went a little too far. I think I spilled some. That's all right, just a tiny bit. Okay, if I put my thumb over one side, then it doesn't matter what I do. I can't spill this water. It doesn't matter what happens. I can't spill it as long as I keep my thumb over it. Why? Because now I've got air pressure going on. The air pressure going down this tube is holding all the water in the tube. So that's a pretty cool concept there too. I can't spill it as long as my thumb is over one side. Now if I were to put it all the way down and poke it downward, then some air could bubble up through here and I could start having some leakage. But let me just try real quick, a quick experiment. Okay, that's pretty good. Still not coming out. I could get it to dribble if I kind of shook it around some, but right now it's still staying in the hose as long as I keep my thumb over the other end. What happens if I take my thumb off for a second? Oop, it's moving down, down, down. Yeah, I can control. Oop, oops, now it's dribbling. Okay, it's kind of fun to play with. Notice also that this works just fine even if part of the hose is above everything else. Notice it's not coming out. Oops, yes it is. What happened? Something went wrong. Oh, that wasn't supposed to happen. Let me try that again. Why did it do that? Because I tipped it so far that air was able to get in on one side, and yeah, that messed things up. I've got to be careful that I don't let the giant air bubble get into this part. But like right now, no problem, as long as I keep that air bubble on the correct side of the loop. I can raise the hose above the level of the water in the tubes, and everything still works just fine. Pretty neat, huh? And there, I can tie knots in this hose and it would still work. It just doesn't matter. It works no matter what. Until I pull this up far enough that my air bubble moves over into the upper part of the loop, and that ruins everything, as you saw just a moment ago. There it goes. Ah, that air bubble's going to cause trouble. Okay, so anyway, there you have it. And that's the end of that demonstration. Hope you enjoyed it. This was in regards to Chapter 13 primarily, with a tiny bit of Chapter 14 mixed in.